When we dissolve a solute in a solvent, that is if we add salt to water, salt is the solute, water is the solvent, and we stir it, we get the final solution. So there are different types of solutions which are possible. We have sand dissolved in water, we have aqueous copper sulfate solution, and milk. These are the three different kinds of solutions, and we'll filter them now. So first, we filter sand dissolved in water. You see that clear water is collected in the flask and sand is left on the filter paper. Next, we filter aqueous copper sulfate solution. On filtering, the entire copper sulfate solution is obtained in the flask. There is no filtrant or residue on the filter paper. Now, we'll filter milk. Again, the entire milk is collected in the flask and there is no residue left on the filter paper. So these are the three different kinds of solutions. One of these is a suspension. The properties of a suspension are that it is heterogeneous. It is the components of a suspension, they can be separated by filtration, and it is not stable. By not stable, we mean that if we leave the solution undisturbed for some time, the insoluble solid settles at the bottom. So which out of the three? Sand dissolved in water, aqueous copper sulfate solution, and milk. Which out of the three do you think is a suspension? Yes, sand dissolved in water is a suspension because we see that it is heterogeneous. Its composition is not same throughout. It is not stable. That is, if we leave it undisturbed for some time, the sand settles at the bottom and we can separate this sand using a filter paper. So this sand dissolved in water is a suspension. So the suspension or sand dissolved in water satisfies all the three properties. Now let's look at another type of solution, that is aqueous copper sulfate solution, which is a true solution. Now what are the properties of a true solution? A true solution is always homogeneous. So when we look at aqueous copper sulfate solution, we see that it is same throughout. Since it is uniform in composition throughout, so it is homogeneous. It is also clear and transparent, as we saw in case of aqueous copper sulfate solution. The components of a true solution cannot be separated by filtration. When we filtered aqueous copper sulfate solution, there was no residue on the filter paper. Also, it is stable. When we say it's stable, if we leave aqueous copper sulfate solution undisturbed for a very long time, we do not see any insoluble solid settling at the bottom. So aqueous copper sulfate solution is a true solution. Now what kind of solution do you think is milk? Well, milk, it looks homogeneous. Homogeneous because as we look at it, it looks the same throughout. It has the uniform composition. But if you take some of this milk and observe under a microscope, you will see that it has varying composition throughout. It has different particles like fats and so on. When we observe this milk under a microscope, we observe that there are different particles in different proportions of milk. So even though it looks homogeneous, it is actually a heterogeneous mixture. So such a mixture which looks homogeneous but it's actually a heterogeneous mixture, the components of which cannot be separated by filtration. There was no residue when we filtered milk, and again it is stable. If we leave it undisturbed for some time, we do not see any insoluble components settling down. So such a solution is known as the colloidal solution. So milk in this case is a colloidal solution. We have chalk powder dissolved in water. What kind of a solution is that? Is it a true solution, suspension, or a colloidal solution? We know that chalk powder is insoluble in water. Since it is insoluble, it can be separated by filtration. It is also not stable. as if we leave it for some time undisturbed, the chalk powder settles at the bottom, and this mixture is a heterogeneous mixture. So such a mixture which has these properties is a suspension. Now we have two solutions. We have aqueous copper sulfate solution and we have milk. To us, both are homogeneous looking, both have the same composition throughout. We know milk looks homogeneous, but it is actually a heterogeneous mixture. But when we are looking at it, to us, both are homogeneous. Both cannot be separated by filtration, the components of aqueous copper sulfate solution and milk. They cannot be separated by filtration. And they are also stable. Both of them are stable. So how do we actually distinguish between a true solution and a colloidal solution? The first way to distinguish between the two is by using the property that true solutions are clear and transparent. If you take your hand and place it behind this beaker, you will be able to see it. Or if you take a colored paper, place it behind this beaker, you will be able to see the paper. But if you take your hand or the colored paper behind this glass, you will not be able to see it. This is because true solutions are clear and transparent, whereas colloidal solutions are not. So this is one property which we can use to distinguish between the two. Another very important property which helps us in distinguishing between the two is something which you must have observed in a dark room. If you have a dark room and you open a ventilator or a small window, you see the path taken by the light rays. Why do you see this path which is taken by the light rays? This is because there are tiny dust particles in the air. As the sun's rays strikes these dust particles, the light rays scatter. As they are scattered, they take a wider area now, so we can see the path taken by the light rays. So the air or the dust particles which are present in air, they scattered the sun's rays, and so the path of the rays becomes visible. And this effect is known as Tyndall effect. Tyndall effect is the effect of scattering of a beam of light. When the beam of a light is scattered by some particles which are present in the medium, their path becomes visible, and this scattering of beam of light is known as Tyndall effect. This is also the effect which you observe in dense forests. In dense forests, again, you see the path which is taken by the rays of the sun. Why is this so? This is because in forests, there are tiny droplets of water. As the sun's rays strike these droplets of water, their path is scattered. As they are scattered, their path becomes visible. So again, it is the Tyndall effect which makes the path of the sun's rays visible. How does this Tyndall effect help in distinguishing a true solution from a colloidal solution? Say we have two beakers, one of them contains a true solution and one a colloidal solution. How can we distinguish the two? We bring a torch. As we switch on the torch, you see that in one of the beakers, the path of the light rays becomes visible. This is because we know that some particles in a colloidal solution, as they are big, they scattered the light rays. As they are scattered, their path becomes visible. So this is a colloidal solution. A true solution cannot scatter the light rays. This is because the particles of a true solution are very small. They do not have the property to scatter the light rays. And hence, Tyndall effect helps us in distinguishing a colloidal solution from a true solution. So we can use this property when we have two solutions. We bring a laser beam or a torch. You observe that the path of the laser beam becomes visible in one of the solutions. This means this is a colloidal solution, and the solution in which the path does not become visible is the true solution. So Tyndall effect is the scattering of a beam of light by the colloidal particles which are present in a colloidal solution. Since the colloidal particles are bigger than the particles of a true solution, they have the tendency to scatter the light rays, and hence the path becomes visible. So Tyndall effect can be used to distinguish a true solution from a colloidal solution. So we see the different types of solutions, that is the suspension, a true solution and a colloidal solution.